For centuries, Betelgeuse has burned above humanity as a deep crimson beacon on the shoulder of Orion. Visible even to the naked eye, its reddish glow has made it one of the most recognizable stars in Earth's night sky, a fixed point woven into mythology, navigation, storytelling, and survival across countless civilizations. Ancient cultures tracked its shifting brightness with fascination. To some, it marked the shoulder of a celestial hunter frozen in the heavens. To sailors crossing dark oceans and travelers moving through desert horizons, its glow became a guide through uncertainty. Yet even in ancient times, observers sensed something unusual about this star. Unlike many bright stars that shine with steady consistency, Betelgeuse subtly flickered. Its light rose and faded in slow, uneven rhythms, almost like a heartbeat echoing across the cosmos. No one understood why. But people noticed. Over generations, the star became more than a point of light. It became a symbol of instability hidden beneath apparent order, proof that even the heavens were not perfectly fixed or eternal. A star beyond comprehension. Located roughly 640 light-years from Earth, Betelgeuse is close enough in cosmic terms that the light reaching us today began its journey when human civilization was still in its early development. Every photon arriving from the star is ancient history made visible. Despite having a cooler surface temperature than our Sun, Betelgeuse shines vastly brighter because of its incredible size. T Betelgeuse approximately equals 350 K. T Sun approximately equals 580 K. If placed at the center of our solar system, its outer atmosphere would extend beyond the orbit of Jupiter, engulfing Mercury, Venus, Earth, and Mars within a single enormous stellar envelope. This is not a calm or stable object. It is a red supergiant nearing the final stages of stellar evolution. A living surface of fire. Modern observations reveal a surface unlike anything found on smaller stars. Giant convection cells churn continuously across Betelgeuse, where superheated plasma rises upward while cooler material sinks back inward. These are not weather systems in any ordinary sense. Some are so enormous that entire solar systems could fit inside a single convective region. Its atmosphere is equally violent. Immense stellar winds push material outward into surrounding space, forming expanding shells of gas and enormous clouds of dust extending far beyond the visible star itself. Betelgeuse is actively shedding its own mass. The elements forged deep inside its core, carbon, oxygen, nitrogen, and heavier atoms, are constantly being released into interstellar space. Those same elements eventually become planets, oceans, atmospheres, and perhaps even living worlds. In this way, Betelgeuse is not only dying. It is helping create the future. The Great Dimming. Then, in late 2019 and early 2020, something extraordinary happened. Betelgeuse suddenly began to fade. Not gradually, but dramatically. Its brightness dropped to nearly one-third of its normal intensity, becoming visibly dimmer even to casual skywatchers. Around the world, observatories turned toward Orion. Speculation spread rapidly. Was this the beginning of a supernova? Could humanity be witnessing the final moments of a dying star in real time? If Betelgeuse exploded, it could become one of the brightest objects ever seen in Earth's sky, potentially visible even during daylight. But as astronomers gathered more data, the explanation became more surprising. The star itself had not truly faded. Instead, Betelgeuse had partially hidden behind a massive cloud of gas and dust expelled from its own surface. A colossal eruption had blasted material outward, temporarily blocking part of the star's light from Earth. The event became known as the Great Dimming, one of the most extraordinary stellar observations in modern astronomy. But beneath that temporary concealment lies a far deeper reality. Betelgeuse is still unstable. And one day, it will die. In Part 2, we'll explore the violent physics unfolding inside the star's core, the terrifying power of the coming supernova, and the cosmic rebirth that will follow its destruction. Deep inside Betelgeuse, nuclear fusion continues in layered shells surrounding its core. Hydrogen fuses into helium. Helium fuses into carbon. And progressively heavier elements form in deeper, hotter regions of the star. But this process cannot continue forever. Eventually, iron begins to accumulate in the core. And iron changes everything. The moment fusion fails, most fusion reactions release energy, helping stars resist gravitational collapse. Iron does the opposite. Fe plus fusion, right pointing arrow energy consumption. Once iron dominates the core, fusion no longer supports the star. The internal balance between outward radiation pressure and inward gravity collapses. And when that happens, the end arrives suddenly. The core will compress catastrophically under its own weight in mere seconds. Then the outer layers of the star will rebound outward in a colossal explosion, a supernova. The energy released in that moment will exceed what our Sun will produce across its entire lifetime. For a brief period, Betelgeuse could outshine entire galaxies. A second sun in Earth's sky. If the explosion happens during humanity's lifetime, it would become one of the most spectacular celestial events ever witnessed. The star could appear bright enough to see during the daytime. At night, it might cast faint shadows across Earth beneath an eerie reddish glow. Yet despite its terrifying power, Betelgeuse poses no danger to Earth. At hundreds of light-years away, the explosion would remain a breathtaking spectacle rather than a catastrophic threat. But one mystery remains impossible to answer. When will it happen? The explosion may have already happened. Betelgeuse could explode tomorrow. Or it may survive for another 100,000 years. From our perspective, both possibilities are equally real. Because light takes time to travel, there is an even stranger possibility. The star may have already exploded. Its final flash could already be racing toward Earth through interstellar space while we continue seeing an older version of the star from centuries in the past. Until that light arrives, Betelgeuse continues its unstable existence. Its surface erupts violently. Massive convection zones rise and collapse. Dust clouds form and disperse unpredictably. The star behaves less like a static object and more like a living system shaped by chaotic forces beyond ordinary human intuition. Death is cosmic creation. When the supernova finally comes, it will not be an ending in isolation. It will become a transformation. The outer layers of Betelgeuse will be hurled into space carrying heavy elements forged over millions of years. Those materials will drift through interstellar clouds and eventually help form new stars, new planets, new atmospheres, and perhaps new life. Our own planet exists because ancient stars once died in similar explosions long before the Sun was born. The oxygen we breathe, the carbon in our bodies, and the iron within Earth's core were all forged inside stars that vanished billions of years ago. In this sense, destruction and creation are not opposites. They are partners in an endless cosmic cycle. A star still wrapped in mystery. Astronomers continue to monitor Betelgeuse with increasing precision. Every fluctuation in brightness, every spectral shift, and every eruption adds another piece to a puzzle that remains incomplete. Despite all modern technology, the star still resists full understanding. It reminds humanity that even familiar objects in the night sky contain layers of complexity far beyond expectation. One day, its collapse will come. And when it does, the event will not simply mark the death of a star. It will write a new chapter across the galaxy in light, matter, and creation. Until then, Betelgeuse continues to burn above Orion, unstable, unpredictable, and profoundly alive with change. A reminder that the universe itself is never truly still.